You are in Mrs. Lewis's class for physical science or for biology at West County High School. What you're looking at right now is the graph from our first experiment for physical science, and I'm going to show you today how exactly this graph should be set up for the particular experiment. Also, I will be making notes as to what you will be graded on and pitfalls of making a graph. So first things first, you must have a title. For the title of this experiment, it's the effects of light on different colored jackets. Make a special note that words are capitalized because it is in fact a title. The main title of a graph should always reflect and represent both the independent and the dependent variable. In the case of this lab, we were testing light for 5 minutes on different colored jackets, 5 colors to be exact. There are 3 different types of graphs we use in science. We use bar graphs, line graphs, circle graphs, or some known as pie graphs. In this case, we will be using a bar graph because we're showing different sets of data and comparing them. A pie or circle graph is not appropriate for this experiment, and the reason why is because it's not showing a fraction, parts of a whole, like 1/4 of the pie, or a percentage, 25% of the pie. And although we use time in the form of a stopwatch, for 5 minutes, to test the effect that the light and the heat that it gave off would affect the different color of jackets. Because I'm testing 3 different types of material for the colors black, blue, green, yellow, and white, I need to have a legend so that people know what it is that I'm testing as far as the results. So wool will be represented in orange, nylon is represented in brown, and denim is represented in green. You can use whatever 3 colors you prefer. At the very bottom of my graph, on the x-axis, I should put the independent variable. And because it is a title, we're going to capitalize it. In this case, the independent variable is the jacket color. That's what we're testing. That's what we're changing on purpose. On the side of the graph, we will put our third table. This is the y-axis. And again, because it is a title, what are we going to do? That's right, title it. So in this case, we were measuring the temperature of the jacket, and in parentheses, we should always use our notation for our SI units. In this case, it's degrees Celsius. Another item to remember for full credit, you should use the entire horizon of a graph and as much of the vertical part of the graph that you can. Notice that even though I had no numbers that went to 33, I still took it to the top. And I could have easily fit black here, blue here, green, then yellow, and then finished with white. But if I'm just using a very small portion of my graph, it makes it hard to read and harder for others to recreate. You may have a way that you prefer to set this up, but this is how we're going to do it for this first experiment. This first line right here at the bottom of your graph, we're going to begin at 0, and then we're going to go up 1 line and mark that as number 1. And then we're going to go up 2 lines and mark number 3. And from this point forward, we go up every 2 lines, and we're counting by 3s. So 2 more lines, 6. 2 more lines, 9. 2 more lines, 12. You get the point, and you end at 33. And then for our independent variable, the different colors that we're testing, black, blue, green, yellow, white. According to my data table, black wool had an average temperature in degrees Celsius of 30.8. So I use a ruler. Rulers are very important. You need a straight line. Okay, so this is 30. Somewhere about halfway, this is going to be 31, then 32, then 33. So my 30.8 is right about there, and that's when I draw my little line. And I go through and I mark each one of these. And when I'm done with that, I'll color it. So I have 30.8 here, 29.1 for nylon, and 29.6. A main question is, do I have to label these? If it were to end right on 33, then no, you wouldn't have to label it. But if it's going to be off a little bit or the number isn't distinctly written right there on the line, it is best for the person reviewing your lab to know exactly what number correlates with your data table. And then once we have the entire graph completed, we can see patterns better than what we could have seen in the data table. For example, I noticed that across the board, no matter what color we tested, brown for nylon was always of a lesser temperature than the orange or the green. And you can see that brown is always a cooler temperature. The second thing I noticed that I didn't see before while I was analyzing my graph is orange always ran warmer from the light than green, or wool tends to be more warm than denim. So if I was trying to figure out for my camping trip in the middle of August when it's at its hottest point what type of material I should wear, it's definitely not going to be wool. And although denim's okay, it looks like nylon is the best way to go. And this is how your lab should look for experiment number 1. As a final note, I cut out my graph and I glued it into my book.